Well, in example number 1, we have to find the domain of the given function, and this function is multivariable function with two independent variables. So here this function contains sum of two different functions. So if I recall the domain of such functions, the domain of f plus g is equal to domain of f intersection domain of g. So here we have two functions. Let's suppose this function is g and this function is h. The intersection of domains of these two functions would be the domain of f. Let's first find the domain for g. So here g contains square root. So whenever we have square root in the function, the term inside the square root should be greater than or equal to 0 to get the defined function. Now let's solve this inequality. Then it would be y greater than or equal to minus 1. So this is the domain for g. Now let's find the domain for h. Now here h has logarithmic term, so logarithmic function is undefined for 0 and all the values less than 0. So here the argument for logarithmic function should be greater than 0. So let's solve this inequality. It would be x square greater than y. Now rearranging this inequality, y is less than x square. So y less than x square is the domain for h. Now the domain for f would be the intersection of these two regions. Let's write it in the set form. So all the ordered pairs which satisfies y greater than or equal to minus 1 intersection y less than x square is the domain for f. So now we would sketch the graphs for g and h. Then we would find the common region for these two domains. The common region for these two domains would be the domain for the given function f. So first we have to find the region for domain of g, and the domain of g is y is greater than or equal to minus 1. So let's first sketch the line y is equal to minus 1. So here it is the horizontal line which passes through y minus 1. So now we have to find the region for domain of f. So y is greater than or equal to minus 1 means the region above the line y is equal to minus 1, and the line is also included in the domain of g. Well, now let's find the domain for h. Domain for h is y is less than x square. Let's first sketch the graph for y is equal to x square. So y is equal to x square is parabola, and now we have to find the region y less than x square. So all the points below the parabola y is equal to x square would be the region for domain of h. Now here the important thing, why I used dashed lines instead of solid line. So dashed lines means these boundary points are not included in the domain of H because there is not used equal sign. So that's why the boundary of y is equal to x square is not included. So the domain of H is all the points below y is equal to x square. Here we have the graphs for the domain of G and domain of H. So now we are interested to find the domain of f, which would be the intersection of these two domains. So let's take the intersection, or we can say the common region of these two domains. So here it is the common region of domain of G and domain of H. So this is the domain for f, which contains all the points of the line y is equal to -1 and all the points above this line and below the curve y is equal to x square. Well, in example 2, we have the multivariable function with three independent variables. So here we have to find its domain. So this is basically four-dimensional surface. So let's find its domain. So here the function includes the square root, and when we have square root, the function would be defined if the term inside the square root would be greater than or equal to 0. So it should not be negative because it becomes the complex number. So here is the condition for the domain of f. Now let's simplify this so we can get x square minus x square minus y square minus z square is greater than or equal to -4. Now let's multiply this whole inequality with negative sign. It becomes x square plus y square plus z square less than or equal to 4. So here it is, if I imagine just the equal sign, x square plus y square plus z square is equal to 4. It is the equation of sphere at origin with radius 2. So now what does it mean by less than or equal? Less than or equal means all the points on the boundary of the sphere and all the points inside the sphere are included in the domain of this particular function. So here it is basically the domain for the given function.